Okay, hello, fellows. Today I want to share with you how to solve a reaction problem with MATLAB. Okay, so I'm continuing our MATLAB tutorial. Uh, in the previous lecture, I showed you how MATLAB is very beneficial to chemical engineering. So in this lecture, I want to share with you how to use MATLAB and solve a chemical reaction problem, a chemical problem where maybe we have a reaction A is being consuming and B is forming. So we were given the initial concentration. We know the reaction rate to the first order. We know the key. We know the value of the key. And we know the time it took for the reaction to take place. So how are you going to how are you going to deal with this kind of problem on MATLAB? So today I want to share with you how to use MATLAB and solve this kind of question. So we'll start. We know our reaction is a first order from A to B. So definitely you're gonna need the constant, the the constant of reaction is the key. So let's specify. So we have to start by saying hash or percentage parameter, meaning we are coming to define our parameter. From then I'll type enter for next. From there I define my key. So key, small k is equal to, let me see, zero point 0.2. So 0.2. Then this type comma. Then I have to type hash again, percentage or hash. Hash for Python, for MATLAB is percentage. So shift percentage. Then I have to define the unit, which is per second, right? So which is 1/second. Then I'll type enter. So from there, I'll define my initial concentration, which is A naught, A naught, which is equal to, from here I'll say 1 mole per liter, so 1 and this, then I'll define my unit is mole per liter, comma, then I'll say initial concentration. Sorry for the background noise. I'm in the mix of colleagues, so sorry for that. From here, I'll define my time, the time it took for the reaction to take place. So I'll see. Let me give it 4 seconds. Oh, 44 is. So let me give 4 seconds. Then from finish, I'll type the percentage. Seconds X. That's it. Okay, from here, I'm coming to define the equation because this basically I use the batch reactor, where we know for batch reactor there's no input, there's no output. Is is the accumulation is equal to the consumption. So because A is consuming with respect to A, so for that we know that kind of equation is what is exponential equation. It's an exponential equation. So we say I'll say CA is equal to CA naught. If you know how to drive um the mass balance for the battery reactor, you know exactly one I'm typing here. So CA naught multiplied by Euler's number E. Okay, then bracket open minus K exponential T. Small t rather, because I define small here. Okay. After that, then after that, I'll type this, then percentage. So I'll see analytical solution. Analytical solution. Sorry, fellows, for the background. No, for the background noise. I'm mix of colors. Sorry for that. So from there, I'll say display CA. I'll display CA. Okay, and then there you are. Display CA, then type enter. There you are. 0.4493 as our CA, which is our output concentration. We know that the incoming input concentration is 1. So the output, because definitely A is consuming while B is forming. So definitely there will be decrease in in the incoming concentration. So you can see here is 0.4493. Okay, from there, so let me tackle a bit of small things. So let me say, for instance, if you have a problem like they are giving you calculate the concentration, like maybe a problem, they have given you the molar flow rate, they have given you the volumetric flow rate, they say calculate the concentration. So from that, maybe let me say let's divide F as what our molar concentration, which is 1.5. Okay, then this, so I'll see H our molar concentration. So let me make it molar, not molar flow rate rather, no concentration, molar flow rate. So I'm clarifying it's molar flow rate. From this, I define my volumetric flow rate. This is V. So V is equal to 3. Let me make it for 3. So 3 this dash is what volumetric flow rate. There you go. So let me define my C as my concentration. Is equal to F divided by V. There you go. So divided by V. So I'll define it as what? Concentration. Concentration and open bracket mole per liter. There you go. Oh, there you go. So from here, I'll just type display C. There you go, 0.5. So see you later. See you in my next tutorial. Bye.